All right, thank you. So yes, thank you so much, Julie, for giving us a fantastic run through on Faustini Rim A area. So we're just going to just continue on with these discussions of this area as well. So a lot of this has already been um, discussed, and so we'll continue this in the discussion section as well. Next slide, please. But I do want to take a moment to just reiterate, like, yes, there's going to be challenges here. There's going to be challenges at every site that we need to be aware of, and it's not just illumination challenges. It's not just cold temperature challenges either. Next slide, please. But it is going to be a very fun treasure map, whatever we end up doing. So it's a matter of, X marks the spot. Where do we want to go explore? And so, what kind of science returns? What kind of science priorities do we want to do? Next slide, please. So I kind of want to go back into these some of the science objectives and some of the science priorities from the Artemis 3 science report. And I'm sure we've all I read that document several dozen times by now, and so what's one more? So next slide, please. This is honestly just a few grab bag science investigations from that science team report. But then, how does Faustini Rim A region fit in with these particular science investigations? So, part one here is the establishing the mechanisms, timing, and extent of volatile depletion. What about the physical properties of the regolith at diverse locations? Next slide, please. Part two in all this would be the identification of the volatiles and microcold traps. What about distribution of the hydrogen on the surface and subsurface? Next slide, please. What about impact melt? So we're sitting pretty in the SPA region. So what does that mean for the different materials from the SPA? How does this address the Great Lunar Cataclysm? And we'll talk about that younger, fresher crater that Julie had mentioned before. We'll get back to that as to how this could also help address this as well. Next slide, please. And then understanding the flux of solar wind and solar energetic particles. So this is going to be an interesting challenge to be sure. Next slide, please. So I'm not going to get into big details on like all the geologic context here. We can certainly go on and on and on about the geomorphologies at this area, and then certainly some challenges with the slopes. But there's still quite a bit of geologic features of interest here as well, and not just, oh, look, a pretty crater. There's other structures here as well. Next slide, please. So nice big one here is not just the boulders and the terrain and the textures of the terrain here though, uh, but myself and and a few colleagues on a completely separate project are looking at angular impact craters, polygonal impact craters, and then proximal uh, pit crater chains in the area as well. So next slide, please. So we do see some of that kind of angularity here with some of the smaller impact craters. So what could that mean? It might mean that there could be some interesting subsurface fracture systems going on here that we could happily investigate. Next slide, please. Uh, just about 16 kilometers away from the center of our Faustini Rim A region, about 16 kilometers northwest of that is a spectacular uh, uh, fault system that just cuts right through a crater, and then just to the south of that. So learning about these different kinds of fault systems, we may not be able to explore per se, but could we essentially have some sort of miniature geophysical network at this area? That would be really cool. Next slide, please. Okay, so let's chat. Let's go back to this cute little crater here. As Julie said, this is about a 2.7 kilometer diameter crater. But what's the significance, though? So why should we care about this crater? Well, in essence, if we want to determine what materials are from the SPA event, having this young crater here and having that sort of material excavated from such a younger, relatively younger time period could help figure out like what kind of ejected materials did it kick up. How does that compare with something outside of that ejecta blanket region as well? So we're wanting to get this kind of diversity of SPA materials versus maybe just Faustini in general. What would we consider to be SPA? And a lot of that has been talked about yesterday. We'll kind of get into more of the statistical analysis of what we believe to be SPA material or not. But having this young crater and learning about the ejecta of this young crater, what has it excavated, can help tune in to what materials have been kicked up about. Next slide, please. So I won't get into slopes, but certainly slopes are certainly an interesting challenge here, though. But next slide, please. Some of the areas that I have talked about, though, are in relatively accessible areas except for the PSRs. Those would be colder and deeper, challenging areas for sure. And some of the materials that we would want to get at, say, the rim of Faustini might be slightly an interesting challenge to be sure. Next slide, please. And then what about the volatiles? So we're having volatiles in not just that small crater, but also near Faustini as well. We're looking at between 20 to 40K temperature differences here. In previous studies, there is a possibility of having some sulfur and ammonia and some organics. And if you're wondering why I'm saying Faustini crater is a Class B PSR, stay tuned because there is a paper imminent regarding classifications of PSRs. So stay tuned for that. Next slide, please. So looking at oh, next slide, please. Well, gotta 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 keep the wrapping up here. So looking at these PSRs and then using diviner data, if the slide would advance, looking at the different kinds of temperature differences here, this in itself is not just great for volatiles, but just volatile interactions. How does this interact with the regolith? How is it accumulated or intermixed with the regolith? Having such temperature differences between summer and winter would be excellent at the rim, because the rim would retain that kind of heat. So, how buried would some of these volatiles be? This would be an excellent site to do that for. Next slide, please. So then looking at the winter average here. So again, looking at how different the rim can be and the different temperatures going on, how can it retain heat? What kind of different volatiles are we looking at? So we're dealing with below 100K. You can have some interesting sulfur and ammonia, and possibly even volatile organics as well. Next slide, please. We're gonna we're gonna kind of skip through this. So yes, there is a potential for CO2 ice uh, around the area as well as far as like sublimation rates go. So that could get interesting at some of the areas around this Faustini Rim region as well. Next slide, please, though. I and also using current ice stability maps. So like I had just said, looking at how deep some of these volatiles are compared to not just day and night, but also just on a seasonal basis. Next slide, please. Mini RF, Julie had pointed out this, the lovely little young crater there has a high mini RF count there as well. So, and even the rim shows some nice variability there as well. So that would be interesting to take a look at. But I'll leave all the cool mini RF stuff for Ed's talk here in a bit. Next slide, please. All right, so now I want to chat briefly about solar energetic particle radiation. So this is an obvious challenge. It's not just slopes and the environment, but also we got to really pay attention to radiation here. So what does that mean? So solar energetic particles, or SEPs, I we can detect these using the Crater instrument from LRO. So if you're not familiar with what Crater is, that's the Cosmic Ray Telescope for effects of radiation. So this instrument can show steady, just background galactic cosmic rays. They are everywhere. They are incident at the lunar surface of all directions. However, these galactic cosmic rays can show a higher flux according to these SEPs. So these flux events are very dependent on solar minimum maximum activity. I but it very much must be monitored very diligently for any sort of human activities. The issue is that we're not that familiar with the radiation environment at the poles at this time. Uh, so exposure is certainly one thing we got to pay attention to. How much of this area is going to be exposed? So next slide, please. Next slide. We're gonna kind of skip through a few. So Earth visibility is certainly something to keep in mind as far as like communications go. Day-night cycles and shadowing. Next slide, please. But in this particular case, how much of the sky is visible at this surface to be exposed for radiation? So next slide, please. Right. So this is where the good stuff happens. So what I'm showing here though is this is a radiation dose from primary protons during an SEP event back in 1989. At the Faustini Rim A region. So darker red colors is bad. This is higher dosage. But looking at like the proximal area around the PSR as well. So having these maps, and don't worry, guys, my colleague and co-author is diligently working to making these maps for all candidate sites as well. So keep your eye out for that. That's going to be really exciting to pop up, so everybody can use those. And with that, I will just say that Faustini Rim does have some interesting challenges, but it can answer a lot of these open science investigations from the Artemis Science Priority list. So thank you.